entiendo español poquito. But I speak like a baby. So I'm going to speak in English. But I'm using this real-time translation from PowerPoint to try to give these subtitles. So hopefully that will help you. I often speak too fast for the English speakers. So I'm going to try to give a nice pace for you. So the title of this is inspired by this book written by an architect, Christopher Alexander. And if you've never heard of this book, it's a masterpiece. And he argues, he's talking about the way that buildings, towns are constructed. And he's saying that there's one timeless way of building. It is thousands of years old and the same today as it has always been. And he builds this language, this taxonomy of different types of buildings, different types of, it's everything from how the town is laid out, to the types of buildings, to where the parks are, to where the doors are, to where the windows are. And it's just a masterpiece. It's a work of art. But first, we're gonna give the alternative title. So this is the history of socio-technical systems. Has anyone ever heard this term or used this term, socio-technical? No? Well, you're going to start using it, or you're going to learn about it today. So I'm going to start with a little quote that I think summarizes most of DevOps, most of a lot of things, but definitely DevOps. So it's in English. For every complex problem, there is an answer that is clear, simple, and wrong. And that's by this guy. He's an American author. Doesn't matter. So I'm going to tell a little bit of my story, how I got here, and why I think what I think and do what I do. So my background has really been at the intersection of open source, cloud computing, and things like agile methodology. So I was a co-founder of a project called Puppet. I worked on that for about 4 or 5 years. Then I was a VP of engineering for an OpenStack startup that got sold to EMC. Then I worked on Cloud Foundry for 5 years. Then I started working on Kubernetes, spent 3 years at Red Hat. In the meantime, I've been part of organizing DevOps days around the world since the very beginning. I wrote some books and blog posts and the rest of that. And then I just started my new adventure with some friends about a year ago that we call Ergonautic. And I come in various configurations of hair and beard. This is my peak pandemic beard. This is where I live, so that's the little cactus. When Raphael picked me up at the airport, he said, "You look different." And I was like, "Yes, I always look different." So next time you see me, I might look very different. So the prelude. So sometimes people introduce me, and they say like, he's a founder of DevOps, and I think that's sort of silly. In fact, I think that's embarrassing. I don't think anyone invented DevOps. I think it's a name for something that had already emerged, and I'll tell you a little bit about that. So I did not invent DevOps. I stole it. And I stole it from my friends. So my advice to you is that good DevOps copy, but the great DevOps steal. And that's a famous quote about artists. So just to get into the story, if you've never heard this before, this is from Velocity Conference in 2009, and I'm sitting in the audience, and John Allspot and Paul Hammond, who are working at Flickr, are talking about doing 10 deploys per day, which at the time seemed like a lot. Doesn't seem like a lot today, but that was a different time. And I was sitting in the audience, and I was tweeting, and I started putting this tag DevOps on the tweets, watching my friends talk about what they were doing at Flickr. And I put a bunch of them. I was already working on this conference with Patrick, and this is something we're going to do later, but my whole reason for this conference is I really wanted to do open space. Because I believe in any conference, no matter who is standing on the stage, there's almost always more expertise in the audience than there is on the stage. So the magic of open space is that you get together with your peers and you get to discuss the problems that you have. This is from 2006. So this is 3 years before DevOps is a word. And Werner Vogel's, there's a very famous quote that's often misunderstood, which I'll come back to later. He says, "You build it, you run it." So that's 2006. This is a blog post from O'Reilly Radar before Velocity starts about how operations is the secret sauce of startups. And he's arguing, Jesse Robbins, who's the founder of Chef, is arguing that in the traditional way, there's a lot more work. So a color on the graph is the amount of human toil, the human work. And in the new way, the new secret sauce way, there's less work. And so this is sort of like the golden age of Puppet and the beginning of Chef around this time. So now things should be even more in this way. Like we should be able to have even more efficiencies. This is a talk I used to give all the time, 2008. I was calling it Agile Infrastructure, talking about the wall of confusion between Dev and Ops, and how if you just communicate with tickets, then people will get unhappy, or maybe even worse. So, and then this is a book that a bunch of us helped write in 2009, and I wrote a chapter in this book that's basically DevOps before DevOps is a word that I called Agile Infrastructure. So for now, and this is in English because the joke works better this way, everything 2006 is before cloud, so that's BC. And then 2009 is after DevOps. So there's 3 years of mystery in between. So I'm gonna jump around a bit. So I'm gonna have a short thread with Deming and then come to something else and then go back to Deming. So does anyone read Deming before? Know who Edward Deming is? If you haven't, you're missing out. But Deming has a bunch of quotes and a bunch of books that are very relevant to everything we're talking about. So this is a quote from Deming. One gets a good rating for fighting a fire. The result is visible, can be quantified. If you do it right the first time, you're invisible. You satisfy the requirements. That is your job. Mess it up and correct it later, you become a hero. Does that sound familiar to anyone? So this is Deming talking about things from the 50s. So Deming was working in the United States in these factories that were making armaments for the war. And he was proving with his methodology that he was getting more productivity and lower costs. And he saw everything as an opportunity to optimize the system. So he's not optimizing one part, he's thinking about the whole factory as a flow through the factory, and it's going to influence so many other things that get to us in this room. So then the war ends, and he's got all this data, but no one will listen to Deming in the United States. And that might have been the end of it, but we'll come back to it in a minute. Meanwhile, in the coal mines of London in 1950s, so this is patterns throughout time. So this is the beginning of the use of the term socio-technical system. There's this guy, Trist. He's at the Tavistock Institute, and he's studying coal miners in the 50s. And what he comes up with, what he's watching, is there's this massive investment in automation, in industrialization. They're mechanizing the mines, and they believe that they're going to get all this productivity from these new mechanized coal mines, but the reality is that's not what happens. But he discovers this new way of working, which I'll show a little bit more detail in a minute, and I'm just going to read this in the English. So the last sentence is what I'm going to focus on. Cooperation between task groups was everywhere in evidence. Personal commitment was obvious, absenteeism low, accidents infrequent, productivity high. So you have this new way of working that has higher productivity and better safety. So the automated way that they're trying to do is called long wall at the time. And the defining fact of the long wall method is that each shift had a different task. So the walls were big and long enough that you took the time, 8-hour shift, and then a new task would come, and then a new task would come. So each team could only really see their individual part. No one that was doing the work could see all of the work. So they had to imagine, and maybe there's a short conversation in between shifts, but the handoff was really between these people who didn't work together. So this is just a way to visualize it. So on the side, this left side is the long wall method. So you have this machine that shears all the coal off. And then this other way, that the Haymore mine that Trist was studying, is called the short wall. So it's more like cross-functional teams deploying microservices that are taking the coal out of the mine. And on paper, the long wall method should have produced higher, more coal. It should be more productive. But in reality, the productivity never really manifests itself. And so the outcome of this study, this work in the 1950s coal mines, is this argument and this definition of socio-technical systems. And the key principle of a socio-technical system, or the key understanding, is that you cannot treat the socio and the technical as separate, that you have to consider them as two parts of a single system. And if you try to focus too much on the technical and then neglect the social, you'll have a bad time. I think the opposite also happens. You have people that are, they're trying to make like Scrum teams or whatever, Scrum Masters, and they don't understand the technical, they don't understand the work, and you need to have that both happen. And then these are from the papers from the 1950s. If we had more time, and maybe I can share some of the references, but I just think it's interesting from papers in coal mines of the 1950s that you can go through this whole list about how these things are related to what we're talking about. I'm going to point out this one in the middle, a tall organization with an autocratic style versus a flat organization with a participative style. And then the very, very bottom, I think, is hilarious, given what everyone talks about now, because in the old paradigm of the coal mines, you have low risk-taking, but in the new paradigm, you have innovation in the 1950s coal mines. Socio-technical system. So more productivity, better morale, and better safety. Who wouldn't want that? Everyone would want that, right? Everyone wants that? You think? It turns out, no. So this research is presented, and the divisional board, the managers, said, no, we're not doing that. They feared the power change would be consequent and allowing groups to become more autonomous at a time when they themselves were intent on intensifying managerial controls in order to accelerate the full mechanization of the mine. So they have all this data that shows that the mechanization of the mines is not producing more coal, and it's not producing better morale, it's not producing better safety, but they're like, no, we're not doing that. So that's awesome. This is the key metric to your DevOps transformation, the mean time to leadership change. If you've never experienced that, you will sometime, I promise. So we would have never heard about Deming if he doesn't go to Japan. So this is the title of a video you can watch on YouTube that's from the 1980s. If Japan can, why can't we? And it's all about Deming, who had went to Japan at the end of the war and basically becomes the foundation of Toyota production system. So Deming taught Toyota how to do this stuff. It becomes Toyota, it becomes lean, and he's explaining in the 1980s to the Americans why they can't build cars as well as the Japanese. And I'll just read this thing from the video. I think that people here expect miracles. American management thinks they can just copy from Japan, but they don't know what to copy. So without Deming, you would never have had Toyota, you would have never had lean, and you would never have DevOps. At least it would look very different than it does now. So when the American executives go to Japan and they see what's happening, they think the Japanese are hiding the truth. They think they're lying to them. And they think they're just making this pageant, this parade for them to see, because they can't conceive of the just-in-time delivery. The continuous delivery of microservices just doesn't make sense to the Americans who are used to stockpiling all this inventory. But what they did see was all the machines. They saw all the robots. And so they go and they invest all this money into building automated factories. And I'll read this in English. The company shelled out an eye-popping $45 billion in capital. So this is $45 billion in 1980. Despite that spending, its global market share rose by but a single percentage point to 22%. For the same amount of money, we could buy Toyota and Nissan outright, said the executive, which would have instantly bumped GM's market share to 40%. So they saw the robots. That's what they tried to copy. They didn't understand the system. They didn't understand the flow. They didn't understand the alignment of the working groups, the cross-functional groups that care about the cars. Because instead of making flawless cars, workers simply did their assigned jobs. It's the same story as the coal mines. Workers simply did their assigned jobs. Workers had no big picture goal of building cars together to motivate them. If you just focus on the technical or the social, you've missed the whole point. All you do is automate the confusion if you're just focused on the technical. So this is all about optimizing for flow. And flow to me is about the structures, the tools, and the narratives, the stories. So this is the history. Now I'm going to bring us to kind of like the present and maybe a little bit of the future, or depending on where you're at, what you're doing right now. So this is what I kind of think of, how I think of the cloud native operating model. And it's also interesting right now because people are trying to pretend like platforms are a new thing, which is hilarious, but we'll get into that. So if you think about each of these layers, this also goes to the definitions of cloud computing from 2011. So in this definition of cloud computing are software as a service, platform as a service, infrastructure as a service. And each of those are now software. And each of those needs to be developed. And each of those also needs to be operated. Now maybe if you're on a cloud provider, you don't have to do the bottom level. But there's no platform out of the box today that you can just buy without doing some development work to make it work for your workflows. And then now it's software that someone better take care of. So we're going back to this Werner Vogel's quote from 2006, you build it, you run it. In 2006, when Werner Vogel says that, he meant run the top level. Only the software, because he's talking about two pizza teams that already have APIs to provision all these other layers underneath and manage and do the rest of that. So he meant run just the software, two pizza team at the top level, platform, infrastructure, or APIs. And we know this because of the memo. So this is a very famous memo from Jeff Bezos in 2002. He writes this thing to the rest of the Amazon, and it says, at the beginning, I'll just give you the beginning and the end. All teams will henceforth expose their data and functionality through service interfaces. And then it's all this stuff about how you can't have databases. And then the very end, anyone who doesn't do this will be fired. Thank you, have a nice day. So this is the CEO saying everything's going to be from an API in 2002. 4 years later, you have Werner Vogel saying you build it, you run it as software at the top level where you already have APIs that do all this stuff for you. So these models came from the Darwinian pressure, the evolutionary pressure to deliver with speed and with the flexibility, the adaptability that we're seeing. This, like, when people try to make all these things separate in their minds, like continuous delivery is separate from microservices, separate from DevOps, separate from platforms, just confusing. It's all the same thing. It's all the pressure to deliver. It's all the patterns from those organizations that had to do that. But the other thing you have to think about is each of these layers has a different pace, a different speed. You're not going to continuously deploy storage and network, the core of the infrastructure. And your platform's going to change a little slower, and your cycle time on the software should be much higher. And so you want to keep these things from delaminating. So they have their natural speed that they're going to go at, but they're also need to stay laminar, in line with each other, aligned. So this is slides that I used to talk about all the time when I was talking about continuous delivery. And the framing here is that you have more risk if you have bigger batches, but that also applies to the socio system, the socio side. If you're not coordinating across teams that are building these systems, and then they diverge from each other, when you come back together and try to reconcile how those things are going to work, then it's going to be a bad time. You're going to have a lot of risk and stuff to sort this out. So one of the things that we talk about a lot in the work that we're doing right now is this notion of socio-technical alignment. And so you can kind of think of like the first thing is you have this top-down alignment. Maybe there's not alignment between things, but there's also this problem that you lose information as you go from the top of an organization to the bottom. The people that do the work have a very different understanding than the executives. And then the middle managers, in some places, their job is to protect the executives from knowing the truth about what's actually going on. But we'll ignore that for now because we're going to get to the second level where the alignment of the mission is actually clarified with the feedback loop. So that the bottom level says, that's not a good idea, and the top level says, oh, okay, well, it'll help us fulfill the mission. So here's the mission. What can we do that will help us win? And then what I consider the highest level of alignment, and this is where DevOps comes in, and it's unfortunate that Dev and Ops kind of frame things just in terms of Dev and Ops, because it's really about cross-functional teams across the whole workflow, right, including security, including quality, whatever, that you have this alignment between the peer levels in an organization. So you have top-down alignment and you have also lateral alignment. So you build it, you run it. A lot of organizations obviously want to run software, but they haven't solved their platform problems, and in many cases have a complete disaster for infrastructure. So just for historical context, these are slides that I used to give about DevOps and high-performing, what I consider the highest performing DevOps in 2014. So I was making this argument about what's worse, I'll say, on this side and better on that side. So in the beginning of a journey, there's a lot of work. Things tend to fail catastrophically. Everyone's focused on incidents. As you get a little better, maybe there's some scripts. People get disaster recovery, and then we focus on the mean time to recover. But in the highest performing manifestations of this, even in 2014, you have platforms that direct the architecture, that have some notion of continuous partial failure. That at certain scales, something is broken all the time, and the platform needs to account for that. This is also in the SRE book. So this is from 2016, talking about SREs building the framework modules so that developers can focus on their business logic. I don't know if anyone ever read that book, but you should. And then this is very explicit language from the SRE book about platforms. A production platform with a common service structure, conventions, and software infrastructure made it possible for an SRE team to provide support for the platform infrastructure while the development team provides on-call support for functional issues with the service. This is from a recent blog post that Adrian Cockcroft made that he called Platform Engineering Done Right, talking about what he considered the platform map at Netflix at his time there. He's since gone. So this is just me putting things that I think are basic patterns that you should be thinking about in terms of, and trying to kind of a little bit go back to the timeless way of building patterns. So if you can't reproduce from source code and get reproducible builds, nothing else is on the table. That's the beginning of any agile engineering practice, being able to reproduce the builds. And then I am a big fan of self-contained deployable artifacts. If you don't have strong identity management, I don't know how you do security. I literally don't know how you do anything if you don't solve identity. Role-based access. Self-service provisioning is the entry level to cloud, in my opinion. That's by definition. And then what people are finally figuring out is that you need to have some kind of service catalog that you can provision with APIs. You need to have some service discovery. I'm a huge fan of things like circuit breakers and load shedding. And last but not least, runtime observability. So this is like a grab bag, and there's a whole bunch of things that I'm leaving out. As you saw from the slide before, this can be quite complicated, even for Netflix. Netflix is actually a pretty simple application compared to what some organizations have to deliver. So if this was easy, everyone would be good at it by now. So everyone wants DevOps, right? Who wants DevOps? Anyone? Anyone in the room want DevOps? All right. Here's what you really want. Here's what you really want. Promise. Here's what you really want. Reliability, availability, scalability, operability, usability, observability, throw in security, sure, why not? For free, without changing anything. That's what most organizations want. So just to make that point, we'll just put that really big. That's what most organizations want. And so the problem here is in this technology lifecycle adoption, that what happens in the beginning, when DevOps gets to become a word, is the people that are early adopters, they want to win a game. They're trying to win. So they're seeking an advantage, and then they get an advantage, and they start measuring it, and they call it Dora metrics or whatever, and then that legitimizes the practice, and then everyone in the late majority, they're not actually seeking an advantage. They just want to use the words. They're seeking legitimacy because the words cross that chasm a lot easier than the understanding and practices. So it's not enough to just copy because we don't know what to copy, right? And this is another Deming quote. A bad system will beat a good person every time. It is not necessary to change. Survival is not mandatory. So don't copy the cloud natives. Seek what they were seeking. And then also related to all this DevOps stuff, it doesn't matter how many times something's been said. It matters how many people still need to hear the message. So go build something. So gracias. I'll try to say this in Spanish. No estoy aquí para responder preguntas. Estoy aquí para tener conversaciones.